In this video, I'm going to show you how to solve a calcium salt conversion calculations question from a viewer, and we are starting right now. Hello, this is Dr. Dankwa, and if this is your first time here and you'd like to learn pharmaceutical calculations tips, tricks, and strategies, then start by subscribing and clicking the bell so you don't miss anything. So let's get right to it. The question says, suppose Amy needs to switch from calcium chloride, which has a concentration of 100 milligrams per milliliter and is taking 8 ml every 2 days for 2 weeks, to calcium gluconate, which has a concentration of 800 milligrams per 10 ml. How much calcium gluconate is needed for this regimen? Molecular weight from calcium chloride dihydrate is 147.02 and that of calcium gluconate is 430.38. So let's do a quick analysis of the question. What is actually happening is calcium chloride is a salt, but the main function of the calcium chloride salt here is to supply Amy with the elemental calcium. So what we want to make sure is once Amy switches from the calcium chloride to the calcium gluconate, she still receives the same amount of elemental calcium. So the first thing we really need to do is determine exactly how much elemental calcium Amy is going to receive based on the dosing of the calcium chloride. So we start off with the 8 milliliters, which Amy is receiving every 2 days. And she's going to receive this for 2 weeks. So what we are doing right here is using dimension analysis. And in every week, there are 7 days. So the weeks cancel out and the days cancel out. The 2 also cancels this 2 out, and you end up with 56 milliliters of the calcium chloride. Now what we now need to do is to take the concentration, which was the 100 milligrams per milliliter, and use that information in conjunction with the volume that we just calculated to determine how much calcium chloride she's going to get in the 2 weeks. And so that would imply that you now have 100 milligrams in each milliliter, and that's going to be equal to some quantity in milligrams divided by 56 milliliters. So that's our proportion. We can go ahead and solve for x, which is our unknown. So x equals 100 milligrams times 56 milliliters divided by 1 milliliter. So the ml cancels out and you end up with 5600 milligrams. Now this 5600 milligrams is actually the amount of calcium chloride that Amy would receive. But what we need is the amount of elemental calcium. So the calcium chloride is made up of calcium and then chloride. And so the way that will work is we can set up a quick proportion and say that the molecular weight of calcium is 40 and the molecular weight of calcium chloride is 147. So we can divide the 40 by 147, and what this is indicating is you have 40, which represents the calcium, divided by 147, which is the molecular weight of the entire calcium chloride. And if you actually multiply this ratio by 100%, it will give you the percent of the elemental calcium in calcium chloride. But we don't really need to do that right now. What we can simply do is set up a proportion and say if 40 divided by 147 represents the amount of calcium in calcium chloride, then how many milligrams of calcium is present in the 5600 milligrams of calcium chloride? So we can go ahead and solve for y, and y will be equal to 40 divided by 147 times 5600 milligrams and that will be equal to 1523.81 milligrams. So the 1523.81 milligrams represents the amount of elemental calcium in the 5600 milligrams of calcium chloride. Now, with this information, we can proceed to determine how much of the calcium gluconate we actually need for this regimen. And the way we will proceed is to start off with a ratio based off how much calcium is actually present in calcium gluconate. Now, the molecular weight of calcium gluconate is 430.38 and the molecular weight of calcium is 40. So what we can do is we can actually set up a ratio saying that the molecular weight of calcium, which is 40, divided by the molecular weight of calcium gluconate, which is 430.38, should be equal to the quantity in milligrams of the elemental calcium that we just calculated, and that was 1523.81 milligrams, divided by the total amount of calcium gluconate, which we do not know. So we can actually give it a variable x, and we can go ahead and solve for x. So when we solve for x, x is going to be equal to 1523.81 milligrams times 430.38 divided by 40. And that's going to be equal to 16,395.43 milligrams. So we now have the amount of calcium gluconate that is needed. However, you're going to give this quantity as a fluid, so we need the volume. That's our main interest here. So we will make use of the concentration of calcium gluconate, which was given as 800 milligrams in 10 milliliters, and we will set that equal to the amount of calcium gluconate, which is 16,395.43 divided by the volume, which would be y ml, because we do not know the volume. That's what we're looking for. So we can go ahead and solve for y here, and y is going to be equal to 16,395.43 milligrams times 10 milliliters, and we can divide all of that by the 800 milligrams, and that should be equal to 204.9 milliliters, or approximately 205 milliliters. So I hope you found this video tutorial useful. If you did, be sure to like it and share it. And if you have any questions, put them in the comments and I'll get to them as soon as I see them. If you'd like to learn more pharmaceutical calculations, tips, tricks, and strategies, then start by subscribing and clicking the bell so you don't miss anything. Thank you so much for watching, and I'll see you in the next video.